Video we are going to talk about position vectors. What are position vectors? So we have the definition that vectors giving the position of a point relative to a fixed origin. Let us see if we have a point P with a coordinate xy, and then the position vector is a vector OP that equals to xi plus yj, also equals to xy in the column vector form. Now, if we have the vector AB, we can see that the vector AB equals to the vector OB minus the vector OA. So, OB is the position vectors of B, and OA is a position vector of A. So we can see we need to relative the fixed origin. Now let's do some example question. For question 1, we have OA equals to 4i minus g and AB equals to 2i plus 3g. Part A asks you to find the position vector of B. Firstly, we can sketch the vector OA and the vector AB. Let us see, here is the origin, and we have the vector OA equals to 4i minus g. So we have 4i over here and minus g. This we find the point A. So we have the vector OA. And let us see the vector AB, that is 2i plus 3g. So we have 2i and plus 3g. So which means you need to start from here. About 3g plus 3g. So we have the point B over here. This we have the vector AB, and to find the position vector of B, which means you need to find the vector OB. Now we can link the OB. Well, you need to find that the vector OB equals to the vector OA plus the vector AB. Well, the vector OA equals to 4i minus g. So we can write it as column vector form, that is 4 minus 1. And the same for the AB, we have 2, 3. So the vector OB equals to 6, 2. That is a position vector of AB. Position vector of B. Now for part B, it asks you to find the exact value of the magnitude of vector OB in the simplified third form. So we need to remember that the magnitude of the vector equals to the square root of x squared plus y squared. So we have 6 squared plus 2 squared. That equals to the square root of 40, and it asks you to write in simplified third form. So we have square root of 40 equals to 2 times square root of 10. So that is the answer. Now let's move on to see the question 2. Given that the point A has a position vector 3i minus 2j, and the point B has a position vector 5i plus 6j, part A asks you to find the vector AB. From the question, what we can have is that the point A has a position vector 3i minus 2j, which means the vector OA equals to 3i minus 2j. And the point B has a position vector 5i plus 6j. It means that the vector OB equals to 5i plus 6j. So we can do a sketch of that. We have the fixed origin, and A has a position 3i minus 2j. So here is 3i and minus 2j. So we have the point A over here. And then the point B has a position vector 5i plus 6j. So we have 5i and 6j. Probably over here, I guess. That is 6j, and here is 5i. So we can sketch the vector OB. This, we can see we have 3i minus 2j and 5i plus 6j. And asks you to find the vector AB. So from point A to point B. Thus, the vector AB equals to the vector AO plus the vector OB. That equals to negative vector OA plus the vector OB. Equals to negative 3 minus 2 plus 5, 6 equals to 2, 8. So this is the vector AB in the column vector form. Now for part B, it asks you to find the magnitude of the vector AB. So the magnitude of vector AB equals to the square root of x squared plus y squared. That is the square root of 2 squared plus 8 squared equals to the square root of 68. And we don't stop over here, since the question said that you need to answer at the simplified third. So the square root of 68 equals to 2 times the square root of 17. That is the answer. So for this lesson, you need to know what is the position vectors and how to use the position vectors to find other vectors. Okay, here is the end of the video. Thank you for your watching.